Learning Target 21 is all on systems of equations, and actually all of the learning targets for the rest of this unit will be involving system of equations. So it's very important that we understand what a system of equations is. And it's when you have two equations with two variables that are being solved together. So the first time we look at systems of equations, we're going to be seeing equations of lines. So they look like slope-intercept form, or y equals mx plus b. So one way to look at a system of equations is graphically, and it's the easiest way to tell what type of solution the system has. There's three different types of solutions. The first is consistent and independent. A consistent system has a solution. If it's an independent system, it has exactly one solution. If this isn't making sense to you right now, don't worry about it. Once we see what the system looks like on a graph, I think it will make a lot more sense. The second type of system would be consistent and dependent, and that would have an infinite number of solutions. And the third type of system is inconsistent, when it has no solution. So let's see what these look like on a graph and see if we can make these terms make a little bit more sense. All right, so when you're determining if a system is consistent and independent, consistent and dependent, or inconsistent, you ask yourself one of three questions. And you can ask these questions in any order, so don't worry about the order that I have the steps written out. The first is, are the lines parallel? Well, in our case, no, they're not, so we're going to move on to the second question. Do the lines intersect? In this case, yes, they do, so I'm going to circle the point where they intersect. That is the one solution to the system. So the system has one solution. And because it has one solution, it is consistent. Consistent, remember, means the system has a solution. And then this is an independent system because it's only one solution. And we'll see what a system looks like with more than one solution. But think about the lines are independent of one another. They have their own slope, they have their own y-intercept. In the blue line's case, it has a different x-intercept. So hopefully that'll help you remember what an independent system is. And then the third question we'll get to later. So we'll start with our first question again. Are the lines parallel? Well, I only see one line, so I'm going to say no. I don't have parallel lines. You need two lines for them to be parallel. Do the lines intersect? Again, you have to have two lines for the lines to intersect, so again, I'm going to say no. And my third question, is it the same line? In this case, the answer is yes. And when the system is graphed as the same line, it has an infinite number of solutions, and it is called consistent because it has a solution, and dependent. And a way to hopefully remember this term is the lines depend on each other because they're the same line. They depend on each other's slope, they depend on each other's y-intercept. So we have an infinite number of solutions because any point on this line, let's say right here or here, any point on this line is a solution to the system. On our last type of system, question 1, are the lines parallel? Yes. So this system has no solution because the lines do not intersect. The solution occurs where the lines touch, and it's called an inconsistent system. Again, inconsistent means no solution.